In Module 3, Lesson 8, we're going to review if-then statements, and then we're going to use them in solving equations. So first of all, if-then statements go something like this. There's one for every operation. And if A is equal to B, then A plus C is equal to B plus C. In other words, if two quantities are equal to each other, then we can add the same number to both sides and it will still be equal. Our second statement, again, if A is equal to B, then A minus C is equal to B minus C. And this one, of course, is saying if two quantities are equal to each other, we can subtract the same number from both sides, and they will still be equal. Our third statement, you're probably catching on by now, is if A is equal to B, then A times C is equal to B times C. And this, of course, is saying if two quantities are equal to each other, then you can multiply each of those quantities times the same number, and they will still be equal. And finally, if A is equal to B, and C is not equal to 0, and that's because we can't divide by 0. It's the only reason we add that in there, because we can't divide by 0. Then A divided by C is equal to B divided by C. And again, it's saying the same thing. If two quantities are equal to each other, then if you divide by the same quantity, which can't be 0 because we can't divide by 0, then those answers will also be equal. So if-then statements are really just saying you can add, subtract, multiply, or divide any number to both sides of an equation, and the answers will still be the same. It follows then that if we have an expression like 3 plus 5 equals 8, an equation like 3 plus 5 equals 8, we can add, subtract, multiply, or divide any number to both sides of this equation, and it will still be equal. So let's try it. If 3 plus 5 equals 8, then 3 plus 5 plus 2 equals 8 plus 2. True? Yes. Let's try it with subtraction. If 3 plus 5 equals 8, then 3 plus 5 minus 2 equals 8 minus 2. True. 3 plus 5 is 8, minus 2 equals 6. 8 minus 2 equals 6. And the multiplication version, if 3 plus 5 equals 8, then 2 times 3 plus 5 equals 2 times 8. Also true. And finally, if 3 plus 5 equals 8, then 3 plus 5 divided by 2 Notice I'm putting them in parentheses so that we know that it's a full quantity, equals 8 divided by 2. 3 plus 5 is 8, divided by 2 is 4. 8 divided by 2 is 4. So we can see that the if-then moves are simply adding, subtracting, multiplying, or dividing each side of the equal sign by the same number. Which brings us to example 1. Julia, Keller, and Israel are volunteer firefighters. On Saturday, the volunteer fire department held its annual coin drop fundraiser at a streetlight. And after 1 hour, Keller had collected $42.50 more than Julia, and Israel had collected $15 less than Keller. Altogether, the three firefighters collected $125.95. We want to know how much each person collected. They suggest to us to find the solution using a tape diagram. Very good suggestion, because to keep track of those three amounts and the changes in them is very difficult without drawing the picture. So we're going to start off with 3 rectangles, each one representing one of the firefighters, Julia, Keller, and Israel. Each of those rectangles are the same size because we will add on or subtract from them based on the information in the problem. It says on Saturday, the volunteer fire department held its annual coin drop. After 1 hour, Keller had collected $42.50 more than Julia. So what we'll need to do is add on to Keller's rectangle. And it says Israel had collected $15 less than Keller. Now remember, Keller had collected $42.50 more than Julia. And if Israel is $15 less than that, Israel's is still a little larger than Julia's. So we'll add on to Israel's, but it won't be as large as Keller's because Keller clearly has more than that. And it says that all together the 3 firefighters collected $125.95. So we represent the total by making a brace. And inside each of these 3 pieces of tape or rectangles that are the same, we'll put an X. Now, the extra parts are the parts where we need to add some numbers. It told us that Keller collected $42.50 more than Julia. So inside this addition, we'll put $42.50. And then they told us that Israel had collected $15 less than Keller. So this portion right here was Keller's, and Israel was $15 less than that. So we'll represent that extra rectangle part as $42.50 minus 15. Once we've set up the tape diagrams, we can write the equation by putting all the pieces together. So our equation is 3x plus 42.50 plus 42.50 minus 15 equals 125 and 95/100ths. Then next, all we really need to do is start combining numbers and like terms. So that would give us 3x plus 42.50 plus 42.50 minus 15 which is 70. Equals 125.95. And then, using an if-then statement, if 3x plus 70 equals 125.95, then 3x plus 70 minus 70 is equal to 125.95 minus 70. And when we do that math, 3x equals 55.95. And if 3x equals 55.95, then 3x divided by 3 equals 55.95 divided by 3. And when we do the math, x will equal 1865. Which means that inside each of these boxes would be 1865. So Julia collected 1865. Keller collected 1865 plus 4250. Which is $61.15. And finally, Israel collected 1865 plus 4250 minus 15, which is $46.15. And we add the three numbers together, we should get $125.95. Looking at example 2, you're designing a rectangular pet pen for your new baby puppy. You have 30 feet of fence barrier, and on a whim you decide that you would like the length to be 6 1/3 feet longer than the width. You need to draw and label a diagram to represent the pet pen, and then write expressions to represent the width and length of the pet pen. So first what we're going to do is draw a pet pen. It's a little rectangle. And you decided that the length needed to be 6 1/3 feet longer than the width. So we'll need to represent the width first of all. And I'm going to represent that with a W. And the length will be represented with W plus 6 1/3. The whole thing has to be 30 feet. That's how much fence barrier you have. So in order to find the dimensions, a pet pen would be a perimeter. We're going to have W plus W plus W plus 6 1/3 plus W and 6 1/3. And that whole quantity needs to equal 30, which is the amount of fence barrier we have. So we have the two widths, W plus W, and then the two lengths, W plus 6 1/3 and W plus 6 1/3. Next, we'll combine like terms. We have 1, 2, 3, 4 W's. And 2 6 1/3, which when you add together will give you 12 2/3. Remember, they equal 30 altogether. Now, using if-then statements, if 4W plus 12 2/3 equals 30, and so our first statement will be if 4W plus 12 2/3 equals 30, then 4W plus 12 2/3, need to fix that, minus 12 2/3 equals 30 minus 12 2/3. And looking at our if-then statements, if 4W plus 12 2/3 equals 30, then 4W plus 12 2/3 minus 12 2/3 equals 30 minus 12 2/3. And then we do our math, and we get 4W, if 4W equals 17 1/3, 30 minus 12 2/3 is 17 1/3, then 4W divided by 4 will equal 17 1/3 divided by 4. And we know that division can be changed to multiplication by multiplying by the reciprocal. So what we're going to do is take 17 1/3, change it to an improper fraction, and then multiply by 1/4, since that is the way we would do that. And when we complete the calculation, we find that the width equals 4 1/3. And in order to find the length, we'll have to add 4 1/3 plus 6 1/3. And so our length should be 10 2/3. Our width is 4 1/3, and our length will be 10 2/3. In example 3, we're looking at Nancy's morning routine, which involves getting dressed, eating breakfast, making her bed, and driving to work. Nancy spends 1/3 of the total time in the morning getting dressed, 10 minutes eating breakfast, 5 minutes making her bed, and the remaining time driving to work. If Nancy spent 35 1/2 minutes getting dressed, eating breakfast, and making her bed, how long was her drive to work? Now they asked us to write and solve this problem using an equation, but I would suggest to you that unless we draw some kind of a diagram, we can't even set up the equation. So let's draw a tape diagram and separate our tape diagram into pieces that will then translate into an equation. So first of all, it says she spends 1/3 of the total time getting dressed. So we'll take our tape diagram and we'll divide it into 3 pieces. Or we'll take 1/3. Then it says 10 minutes eating breakfast. We'll separate a little piece off of there. 5 minutes making her bed, separate a little piece there, and the remaining time driving to work. It tells us that Nancy spends 35 1/2 minutes getting dressed, eating breakfast, and making her bed. And we want to know how long her drive to work was. So we have 1/3, 2/3, 3/3. And we know that the total time that it took her to get dressed, eat breakfast, and make her bed was 35.5 minutes. We know that eating breakfast was 10 minutes and making her bed is 5 minutes. And we should also label eat, and this is her bed. And the rest of this is driving time. Now don't be misled by the fact that your diagram perhaps looks like it's half or something, some other fraction, because you drew the diagram. So there's no guarantees of anything. We do, however, know, first of all, that this getting dressed part is 1/3 of the total. And so at some point in our problem, that piece of information is going to be very important. Right now, however, it appears that we know something really important, and that is that getting dressed plus eating plus making her bed is a total of 35.5 minutes. But we know how long it takes to eat and make her bed. So what we're going to do is use that information, all of it, to make an equation. And our equation is 35.5 minus 10 minus 5, because if we take the total of these three and subtract the 10 and the 5, is equal to 1/3 of the total time. 35.5, this section, minus 10 minus 5, is equal to 1/3 of the total. So now if we take our numbers and we do the calculations, 35.5 minus 10 is 25.5, minus 5 is 20.5. So 20.5 is equal to 1/3 n. And then to solve, if 1/3 times n is equal to 20.5, then let's write our if then. If 1/3 n equals 20.5, then 3 times 1/3 n will be equal to 3 times 20.5. And when we multiply 3 times 1/3, we get 1. 1 times n. That's our goal. So we would then say n equals, and we'll need to multiply 3 times 20.5, which will give us 61.5. So the total amount of time is 61.5 minutes, but that's not what they ask us. They asked us how long her drive to work was. So we'll next need to take that piece of information, 61 1/2, which was the total amount of time it takes to get ready, and subtract 35 1/2. Which is how long it takes her to get dressed, eat, and make her bed. And 61 1/2 minus 35 1/2 is 26 minutes. And our final example, the total number of participants who went on the 6th grade field trip to the Natural Science Museum consisted of all of the 6th grade students and 7 adult chaperones. 2/3 of those participants rode a large bus, and the rest rode a smaller bus. If 54 of them rode the large bus, how many students went on the field trip? So let's draw, again, a tape diagram to represent. And let's section it off. It said all of the 6th grade students and 7 adult chaperones. So we'll separate a little section there. And it also said that 2/3 of the total participants rode a large bus and the rest rode a smaller bus. So we'll divide the total tape diagram into thirds. Keeping in mind that this little section here were 7 adults. And 2/3 of the total participants rode this large bus and the rest rode the smaller bus. And this is 2/3, which is the large bus. The rest is the small bus. Now it tells us that 54 of them rode the large bus. So we know that this section, 2/3, is the large bus. So we can use that information to set up our equation. These two pieces are 54. And what we really don't know is this piece here. So we'll name that X. Now what we know then is that this section, X plus 7, equals 1/3 of the total. So when we divide 54 by 2/3, it's the same as multiplying by 3/2, or the reciprocal. And we find that n is equal to 81. N being the total. And the question was, how many students went on the field trip? Well, the total number of people who went on the field trip is 81. And so 81 minus the 7 chaperones will be the total number of students who went on the field trip. So there were 74 students who went on the field trip.